Okay, now we resume the class. Now the other features in the class including the scope operator, which represented by double colon. And the function of the scope operator is that if you are going to declare your function outside the class, then you should use the scope operator, just like the example. Now originally, your class rectangle contains a function, so-called set values. If you do not declare the set value function within the class, so that you write your code inside the class, you should using the syntax scope operator by first tell the compiler that this function belongs to the rectangle, and then the scope operator, and then your function name. Okay. Now by using this approach, actually, after you write your code, the operation is exactly the same inside the class. Okay. Now, for every class, it has the constructor, and the main purpose of the constructor is to initializing the object. For example, it may give some initial value of the variable inside the class, and the name of the constructor is exactly the same to the class. So, for example, if you have a rectangle class, and if you are going to have a constructor, then you have the same name, and then you have the parameter list for declaring the class. Okay. Now you can see that here we also using the scope operator, that the constructor is declared outside the class. So we're using the scope operator here. Okay. Now, so when you declare the constructor, it looks like the regular member function, but the length should be matched with the class length. Okay, and it does not contain any return type. Now, like other functions, now we can overload different versions of the constructor. Now, overload, it is a feature of C++ because you have multiple versions of the function. For example, for addition, you may have 2 parameters, or you may have 3 parameters. Okay, so when you have the function call, the program will automatically assign which function is going to serve your program. So constructor is the same. It can have different functions because they can have different number of parameters, or the parameters may have different types. And the compiler will automatically call the one whose parameter match the arguments. And for example, in this rectangle class, we have 2 constructors. One is so-called default constructor because it requires no parameters. Another one, you are going to pass 2 parameters into the class. So we can implement each of the constructor one by one. The default constructor, you can see that it tells the width and height variable they are equal to 5. But for the constructor with 2 parameters, they will substitute a equal to width and b equal to height. Okay. Now, so you can see we can call the or we can declare the object in your main function, and using these 2 constructors. The first one you are passing to data. The other one you only using the default constructor. Now, similar to the structure, you can declare the pointer to the class. Once it is declared, a class becomes a valid type, and it can be used to point to by the pointer. Okay, just like the example here. Now we declare the rectangle class, and we declare a object, rectangle object, initialized with 3 and 4, and we declare some rectangular pointer object. Okay, so when using the object, you can see that you can give the address of the obj into full, the first one, the first pointer, or you can using the new to construct or allocate memory to the object, bar object and BAC object. Okay, so as a result, you can see we have 3 pointer to use, and the first one, it is pointing to an ordinary object. The second one, you are using a dynamic allocation of memory to declare a new object. For the final one, you declare you declare a rectangle object array. Okay, so it can be accessed by putting a 0 or a 1 into the square bracket. Okay, so at the end of the class, please remember to delete the object you have dynamically allocated in order to release the memory for later use. Now, to access the data or function inside the object, you should use the arrow operator. Therefore, you can see in this example, for the full and bar pointer, when it is calling the area function, it using the arrow operator. Okay, now but for the BAC pointer, because it is allocated as an array, therefore we using it as a ordinary array, that we using a dot operator to call its function instead of using the arrow operator. Okay, now here we introduce to you the keyword this, and it represents the pointer to the object whose member function is being executed. Okay, so this refer to myself actually. Okay, it means it is the address that of the object you are using. Okay, now if you have a function or mainly a function, if you are going to call the class member function, you may using this function. For example, in here you can see that we have a dummy class, and we have a function is itme, and which receive a parameter an address of dummy. So this function, it is going to whether the address of the object equal to itself. If it is true, it returns true. Otherwise it returns false. Okay. So when you call this function, you have now you can see we declare one object A and one pointer B, where pointer B is pointing to the address of A. So when you calling the function, because A and B have the same address, so you may expect the sentence yes and A is B will be called or displayed on the screen. Okay. Now, one of this keyword is that it can check whether it is a parameter passed to a member function to be itself, that we have already shown in this example. Now, the other features including static members. Now, you can declare a static members, either data or function, when you have static member in the class, that means, for example, if I have a we have a static members. If you declare two objects B and C, this is class object B and object C. Now they will have the same memory for the static data, so that they share the data by using the static variable. Okay, so we say that the static data member is known as class variable. It has only one common variable for all the objects, and they share the same value. Okay, so if B changing the static variable, C will examine the same change. Okay. On the other hand, now you can declare an object of a class to be a constant object. Now constant means your object data outside the class should be read only, so that you cannot change the data inside the object, inside the class. But still, the constructor of the class can allow to initialize and modify the data members. Okay. Now finally, we have the destructor. Now destructor, it is the opposite of the constructor. It is going to deallocate the memory of the object in order to release the resources for the program. Okay. Now after we introduce to you this OOP implement by using C++ language, now we come to the part for describing the Arduino objects. Now basically, in order to make the programmer to become easier to program, now some of the library are using objects in the programming, because it make our or the programmer to write their program easily. Okay. Now the first one we are going to introduce to you is the serial object. Okay, and it is used for communication between the Arduino board and the computer or the other device. And we have told you that if on Uno board, we using pin 0 and pin 1 for communication with the computer. That means using the USB, just like the picture shown to you. And you can separately using the serial ports using pin 2 and pin 3. Okay, and they are known as the UARTs. Okay, and you can connect the built-in serial monitor of the board, so that you can pin on your computer the data using the serial port to output on the computer. Okay, and the serial communication on pin TX, TX means transmit, RX means receive. They're using the TTL logic. Okay, TTL means transistor to transistor logic, and they can using either 5 volt represent a high level, or 3.3 volt to represent high level. Now for the function, you may find that for the serial object, it implements many functions, so that whenever you use this function, you may issue the statement stereo, for example, read, and then you can call the function. And you can see that the method or function are including in the object. Okay, and it is using the OOP approach in order to make the programmer become easier to write their program. Okay, now here we describe some of the function for the purpose of the function to you. The first one is serial. Serial means it check whether the serial port is ready. Available, it is going to get the number of bytes available for read from the serial ports. Available for write, that means it get the number of bytes available for write to the serial port. Okay. Begin, like we are going to set the bit per second for the serial port, and it control the speed of the serial transmission. On the other hand, end means you stop the serial transmission. Now for the function farm, it is going to search a data from a specific data in the input bit stream, so that you search, for example, it is our input stream. You are looking for some particular data, for example, a 70. You check whether 70 is inside your data stream. Okay. And similarly, we have found until. Found until it is mainly using for check inside a string. Okay. And found you can use as any data. Okay. And for fetch, it is a function that waits for transmission for all the output data complete. Okay. Now because your Arduino, if you don't wait the output device to completely write out the function, you may lose some of the data at the end of the transmission, because the Arduino will switch to do another operations after send out the serial transmission. The next one we have playful, that means it is going to return check whether the first the data stream containing a valid floating point number. Okay, if the data stream containing a floating point number, it will stop. Similarly, place integer means it check whether the data stream containing a valid integer. The peer function, it returns the next byte of incoming serial data without me remove it from the buffer. Now, because serial operation may consider to input or output the data byte by byte, but remember the Arduino support a data type word. That means it is equal to 2 bytes. Therefore, you may use the peak approach to read 2 bytes from the data source or output to the device in a whole of a word instead of higher byte or lower byte. So using the peak function, you can store the first byte from the data source and then together with the second byte to form a complete word. Now for the pin function, it is used for send out or pin out the ASCII character. Pin ln, it is going to pin a character, ASCII character, with a carriage return. Read, it is going to read an integers. Bytes, it is going to read a bytes. Read bytes until it means it is going to read the character until the determined length has been reached, or timeout of the serial command or serial port, or the terminator is detected in the input stream. Read string means it is going to read a string from the input, and read string until is dissimilar to read byte until, because it will stop when the length is exceed to the string length, or timeout, or the terminator character is detected. You can set timeout, okay, the timeout value in milliseconds in order to not hold the serial port too long. And you have write function in order to write some data output to the device. And finally, you have the serial event. Now, this is a what we call the event handler. Okay, it looks like an interrupt, so that when something happens, the event handler will invoke a function to serve the event. Okay, and this is very common for in the OOP language because it is going to respond to something. So it implement the event handler. Okay. Now here we have an example. You can see in the setup function, we only set up the serial port with a baud rate or bit per second equal to 9600. And then you are going to output a character, okay, from 0 to 64, okay. So you pin the character output. Now if you do not specify the format, it using a decimal number, okay, and then you pin a tab, that means around 4 space, you have the next pin out, the same character actually, okay. This time you have the has a decimal number and then a octal number, binary number, okay. And at the end, you can see here we call the pin ln, so that after this character is pinned out, it will jump to an next line, okay. And then hit delay again and pin another character returns, and then start to pin the function, pin the character again, okay. And normally the Arduino do not connect any display device, therefore you needed to have the serial monitor to see the output. Okay, now another object, we have the stream object. Now stream actually it is using to some stable serial data transmission, so that the data arrive will have some variation, and this can appear in our internet because we cannot guarantee the speed to be a constant, and data may come to the device at different time. Therefore, we normally implement a buffer to store the input data, and at the same time the device may consume the data to process, okay, just like you watch to YouTube video. And at the beginning, you can see the payer will buffering the data in order to store some initial data so that it can continue to pay, and at the same time the data will be transmitted to the buffer, okay. So the buffer, it is using the first in first out approach to give out the data, okay. Now normally the stream object will not be directly called, and it will be invoked in any function relies on it, and you can find the stream object in serial object, wirecard object, Ethernet object, or SD card object. And here you can see we have an example that we make the Arduino connection to a video streaming device because this device may transmit the video data to the Arduino, but it may have varying speed. Therefore, we implement the stream object in order to buffering the input data in order to doing the face recognition. Okay. Now you can see the function in the stream object is more or less the same to the serial object. Therefore, we don't repeat the description here. Now another object you may frequently use, it is the SPI object. Now because nowadays, when you buy a hardware from the market, normally it is interfacing by using the SPI approach or using the I2C approach. Now therefore, if the hardware support the SPI transmission, you should use the SPI object. And it is the object to communicate using the SPI method. and you are using Arduino as the master device. Now, when using the object, now you should include the library by putting the header file spi.h in your sketch file. And remember, we have already told you on Arduino pin 10, 11, 12, 13 slave select. MOSI means master output slave input pin. MISO means master input slave output pin. SCK means the clock. Okay, we're using these 4 pins to control the SPI. And also in Uno board, it includes a IC SP header, in-circuit serial programming header, in order to facilitate your connection to the SPI device. That means without using the jumper wire, you may directly using the header to plug into the header onto the Arduino board. It may make you to connect the SPI device easily. Now here we have some functions of SPI. Now firstly, the SPI setting. It is an object for configuring the SPI ports so that you may configure the speed, data order, so that you may transmit the least significant bit first or most significant bit first. And you can consider the mode of the SPI. Remember, we introduced that for SPI it has 4 modes. The mode number from 0 to 3, and it specifies the phase of the clock and whether or you are going to trigger the data from the positive edge or negative edge. Now for the begin function, it is initialize the SPI bus, and means you are going to terminate the SPI transmission. For the begin transaction, you are going to initialize the SPI transmission together with the SPI setting. Therefore, by calling this function, it is equivalent to set this one and also the begin function. And similarly, for end transmission, you are going to terminate the transmission. Set bit order, it means you are going to have the most significant bit transmit first or the least significant bit transmit first. And you can set the clock divider. Normally, our Arduino may operate at 16 MHz. If you are going to set the transmission of SPI to a lower speed, you can set a clock divider. For example, you may set the SPI operates at a frequency 4 MHz. That means you are going to input a 4 into the set clock divider function, so that it will divide the operating frequency by 4. As a result, you have 4 MHz in your SPI operation. You can set your data mode from 0, 1, 2, 3, and you have the transfer. That means if you perform a simultaneous send and receive. Now remember, for the SPI and transmission, at the same time, the master will send a bit to a slave, and the slave will send its bit to the master at the same time. Okay, and finally, you may use interrupt during the transmission. When using this function, that means the SPI device can be interrupted. And when another device call an interrupt, it will stop the transmission, so that the Arduino will serve the interrupt routine. Okay, after the interrupt routine completed, it will return back to the SPI transmission. Now here we have an example, and we are going to connect a barometric pressure sensor, BPS. It is going to read the air pressure and temperature from the part number SCP-1000 BPS sensor using the SPI protocol. And the hardware required, you may have the Arduino board or Genio board. You have the sensor and some wires, hook-up wires. And you can see we have the schematic and circuit. And again, as I told you that before you construct your circuit, you should draw your schematic first. So this is the Arduino board and this is the sensor, and you should clearly state where the wire should be connecting to. Okay, you can see on the device you connect SCK, MOSI, MISO. Okay, and CSB means it is going to select the device, and data ready, it is a pin to indicate the sensor has a data to be ready to send to the Arduino board. And then by using the schematic, you can construct your circuits. Okay, and firstly you may using some software to draw your circuit. Okay, and then you can implement the hardware. Now here we have the program, and you can see we are using the SPI object, therefore we should include the SPI header, and we declare some parameters. Okay, and they are the register values which will be used by the program, and the command and read command and write command they are in the binary string. And we declare the pins for the pin 6 and pin 7. Pin 6 is connecting to the data ready pin, and pin 7 it is going to select the sensor. Again, in the setup function, we set up the transmission rate to 9600, and then you begin the transmission. You set the pin, for the pin 6 and pin 7. Pin 6 for the Arduino, it is a input pin. For the pin select, it is an output pin. Okay, and then you configure the device to a low noise configuration by writing some control character into some registers in the sensor. Now, normally, when you are using the sensor, you should read this data sheet, okay, in order to know how to make a proper configuration of the device. Okay, and the data sheet will tell you how to configure your device. And at the same time, I may say, nowadays, when you purchase a sensor or other device from the market, it will accompany with a sample code. And normally, you can include your sample code into your program, and then modify the sample code, and you can achieve your function. Okay, and this make our development cycle become faster. Okay. Now here we have the loop function. Again, we set up the mode for the sensor to become high resolution mode. And then you check whether the data is ready, so that when it is high, it will read a register and put into the temporary data. Okay, and then you will make the conversion of the data to become a Celsius degree. Okay, and the output panel is our serial monitor. Therefore, we are using the serial object. Now, by default, the serial object can be automatically used in the Arduino IDE. Therefore, you do not require to input the serial.h in your program. Okay, and then you are going to read the pressure. Okay, again, through the function with register function. Okay, you control the register with the address 1F, and you putting 1 to indicate you are going to read the data into the parser. Now, but the parser from the program, you can see that it is a 20-bit, should be 19-bit data. Now, therefore, after it will separate the data width in two parts. Firstly, it read the first the most significant 3-bit to a parser data high, and this operation will ignore the first 5 bits and only keep the least 3 bits in the data. Okay, because when you are doing the AND operation, it will give out according to the truth table. Now, if this is a 1, always a 1. If the data is 0, it gives a data 0. If the data is 1, it gives out a 1. And normally, if the bit is 0, the output should be always a 0. So it will mask the first 5 bits in your high bit data. After reading the high bit data, you are going to read the low bit data. Okay, and the address is 20. Okay, and then it is putting in the parser data low, and then you declare another data parser with a long data type, so that you combine the two data into a single data. Okay, and then divide by 4 so that it scale down the size of the data. Okay, now for calling this function, parser data high, this operation it means a logical the bit shift left operation, so that this bit will shift by 16 bits. Okay, and then or the low operation. Therefore, altogether you have 19 bits of data, and the resulting data will divide it by 4 in order to get the correct parser data. So at the end, after you compute the parser data, you output the parser on the serial monitor. Now for the read register function that we use in the loop function, we have the declaration here. You can see it declares some variable in byte and in result, and it will show something on the serial port. Okay, and then you input the register shift left by 2 bits in order to align the proper position of the register in the sensor. Okay, and then now why we shift the data by 2 bits? Because the lowest 2 bits, it is the control character. You can either control it is a read, write, or write operation, or the other operations. So you pin after you shift data, you pin this register, and then you write it to make the sensor to become selected. Okay, and transfer the data. And because we know that in the SPI, the master and slave will shift in and out the data at the same time. Therefore, at the same time, it will get the result from the Arduino board. And now you minus the byte to read because you may indicate the number of bits to be read or write. Therefore, if it is not completed, you will continue to read the byte. by shifting the result by 8-bit, and then transfer the data again, and then combine the result to a single result. And the process will be continued until all the data has been written, specified by the byte to read numbers. Okay, and after the data has been read completely, we release the sensor by deselecting the sensor by writing pin 6 to become high, and then return the result. And here we have the write register function. It's doing the reverse of the read register. It also shifts the register. That means the address of the register in the sensor, and together with the write command. Okay, and then again select the device, write the data, and then finally you set high to deselect the sensor. Okay. Now here we show you another object that we frequently use. It is the wire object, and as I said, we may use I2C to make the connection to some other device. And wire object, it is the library that is used by the I2C or chain wire interface device. In Arduino, it is using A4 and A5 pin for the I2C transmission. One is for data, one is for clock. And to use the object, you should use the wire.h. And you can see we have the function, some function implement. And we have begin. Begin, it means initiate the wire library and join the I2C bus to become a master or a slave. Request from, is used by the master to request bytes from the slave. Begin transmission, it is going to transmit the data to the slave. And after you complete the transmission, you may call the end transmission. And you can have write data, okay, to write a data to the slave. And you can have available, just like the same, to set to get the number of data to be ready to reading into the master from the buffer. Okay, you are going to read a data from the device. Now set clock means the function modify the clock frequency of the transmission. Now lastly, we have two event handler function on receive and on request. Okay, now in other words, they look like the interrupt because when some event occur, okay, then the on event or on receive or on request function will invoke to handle the event. Now for the on receive function, it is used by the slave device. When it is receives a transmission from a master, it will do something. For the on request handler, it is used by the master when it is requested by the data transmission from the slave device, and it will do something. Okay. Now on the right hand side, you can see that we can use I2C to connect some more than one device for the Arduino. For example, we have a ultrasound sensor. At the same time, you may using the other pins to connect to the LCD display. Now here we have the example. You can see the function will call the wire library, and at the setup function, you make the Arduino join the I2C bus, and then you begin the transmission by waiting for 44, so that it is the device address. Okay, and you can check with the datasheet. It will show you which address of the device it is using when it is connecting to Arduino, and then you can write value and transmission, so that you are going to select the device connecting with the address equal to 44. And the value you are going to write is reading from 0, and then you are going to increment the value until it reaches to 63, because when the data come to 64, it will reset the counter to 0 again. So you can see the Arduino will continue writing 0, 1 up to 63, and then 0, 1 up to 63 to the I2C device. Now here we have showed you another example that we show how we can make the Arduino to connect to a I2C LCD display. And what you needed to in this project is to acquire a 16 times 2, that means 16 characters, 2 volts I2C LCD display. You have a Arduino board, some jumper wires, and USB cable to connect to your personal computer. Okay, now this circuit shows you the connection of the Arduino and the LCD board. You can see we simply connect 4 wires with the ground, VCC, and also the A4 and A5 for using the I2C. And you can see the table for the connection here. And before you write your program, you should include your library for the liquid display library and also the wire library. And you may include the library by using the include library command in your user menu. And also you are going to add the zip library. If the library does not contain in the list, then you should manually install your library to the Arduino IDE. Now here we have the sketch of the LCD. This sketch, it is going to finding the address of the LCD. So you can see that at the beginning it connect the serial port with a speed 9600, and then it is going to doing the I2C scanner, and it check the address from 1 to 127. Okay, if you send the transmission by using the I2C method, and it will return you a value. Now this variable so-called error, but it may not be an error. It can be the correct detection. So under the correct detection, it will have become a 0. That means a I2C device is detected. So it will print out the address. Okay. For example, now the address is 27. When running or executing this statement, you may see correspondingly it will show out a 27. Okay. And it will check completely from 1 to 127 until all the I2C address has been threaded. So now if the error equal to 4, that means actually it is an unknown address. Or if n device equal to 0, so that at the end, if you do not increment any n device, then that means no I2C device has been connecting to the Arduino. Okay, therefore this sentence will be reported and in the serial monitor. Okay, now by using this program, we know that the LCD address is 27 in hexadecimal number. Now the next example will show you how can we display something on the screen. Actually, now you can see we include the wire and the liquid crystal object in your program, and you declare an object liquid crystal, and it is named as LCD, and you give it the initial value calling the constructor. Okay, so the address is 27. Okay, and 20 characters and four rows. Okay, you can have different configuration for your displays. And for the setup function, you initialize the LCD and set the backlight, and you pin the hello world. Okay, you just issue the LCD pin command. Before you do that, you should set the cursor. Okay, because a cursor means the position where you are going to pin. And after you pin out hello world, you jump to 2-1 position and then pin the LCD tutorial. Okay. Now the result may somehow like this one, but it may not be correct because the hello world should be moved to here, and we don't have this for free row, but in here we should have the LCD tutorial. Okay. Now here we come to the end of the lecture, and in this lecture we not only introduce to use some advanced programming technique in C or C++, including array, pointer, dynamic memory allocation, and also the OOP. And we also show you the technique on using the Arduino object. Okay. Now we hope that we can have some experiment for you using Arduino, and we will make the announcement to you later. Okay. Thank you.